Welcome to 1.2, Solving Absolute Value Equations, Part 1. We're actually going to divide this into two parts. So today we're going to do situations where the absolute value equals a number. So for the first example here, I actually have a graph attached to it. This is showing the solution to the absolute value of x minus 5 equals 7. And what I've done here is I've taken the two parts to the equation and just split them along the equal sign. And I've turned them into two different graphs. Y equals x minus 5, which is the V shape in red that you see, and y equals 7. So if you graph both of those, what you're looking for to find the solution is where the two functions intersect each other. So you can see that over here on the left and over here on the right. Now, when we solve an equation, notice the original equation didn't have y's in it. It only had x in it. So when you're solving, you're looking for the x value. So solve is look for x. And in Desmos, it can make this pretty easy for you. So notice I've graphed y equals absolute value of x minus 5. I've graphed y equals 7. And I look for where they cross each other. Well, if you notice, Desmos gives you these gray dots all over the place. And if I click on the gray dots where the two functions cross each other, it gives me a lot of the information that I know. It actually gives me more information than I know. Because if you notice, both y values are 7. Well, that's because this is a 7 over here. I want the x values. And so those x values are -2 and 12. So I'm going to go back to my notes. And if I were doing this by hand, I would look straight down and see that I was hitting x equals -2 and x equals 12. Desmos can actually do this a different way for you. Let's hop back over to Desmos. And I'm going to X out. Let me pull up my keyboard, if it will let me. And I want to put in the actual problem. So I'm going to put in the equals 7. Now, if you notice, and if the keyboard stops popping up, I get two straight lines. I don't even get the absolute value graph. I get two straight lines, but look at where those two straight lines head through. -2 and 12. So those were the answers. Sometimes on this, you can actually get a gray dot to pop up, but sometimes you can't. So it's good to know how to solve this both ways, because Desmos will give you the gray dot if you do it the first way that we talked about, but it won't always give you the gray dot when you do it this way. Okay? And sometimes you do have to do these things by hand. So let's talk about what happens when we have to do these by hand. When you solve an absolute value, notice there are two parts to this function. There's the left part that has a negative slope, and then, so this part right here that has a negative slope, and this part right here that has a positive slope. So absolute value, if you remember back to when you first learned it, can be positive or negative. So if we talk about that a little bit deeper, I can take the absolute value of -4 and I get 4. But I can also take the absolute value of +4 and get 4. So I have to worry about, how am I getting in this problem the 45? Is it because what's inside the absolute value is positive? Or is it because what's inside the absolute value is negative? Because there's two ways to get there. So I'm going to set up two equations. I'm going to set up one equation where everything looks exactly the same. So there's 5x minus 10 equals 45. Then I'm going to set up the same equation, but I'm going to put parentheses around the left side and make it negative. I have to put the parentheses because the whole thing is negative. And so that's going to say, what if what's inside the absolute value is positive, like we have here on the left, And what if what's inside the absolute value is negative, like we have here on the right? And then I can solve both of these. So I can add 10 and get 5x equals 55, and then divide by 5 and get x equals 11. When I solve the right, there's a couple of different ways that you can look at this, but what I like to tell people to do is to use distributive property on the negative. So make this negative 5x plus 10 equals 45. Then I'm going to subtract the 10 and get negative 5x equals 35. Divide by negative 5 and get x equals negative 7. And there are my two answers, 11 and negative 7. Okay, let's try another one. So the next one, we have absolute value equals 4. So I'm going to set up one equation that looks just like it, but with no absolute value bars. I'm going to set up another one that has all the same pieces, but I'm going to put parentheses and a negative in front of the parentheses. So the one on the right I can solve like normal. I can say minus 6 and get negative x, don't forget that negative, equals negative 2. Divide by a negative 1, because that's what negative sign is, and get x equals positive 2. I can distribute the negative sign and get negative 6 plus x equals 4. Add the 6 and get x equals 10. So 2 and 10 are my answers. Okay, let's try another one. So I'm going to set this one up the same way. I'm going to say 3x plus 14 equals 7. I'm going to say negative parenthesis 3x plus 14 equals 7. I'm going to subtract 14 from the equation on the left and get 3x equals, let's see, that's big for my brain over summer. So that's 14, 13, 4, oh yeah, it's 7, isn't it? It's negative 7. Divide by 3. It's an ugly fraction, but that's okay. Sometimes that happens. And I'm going to say negative 7/3. Then I'm going to distribute and get negative 3x minus 14 equals 7. I'm going to add 14 and get negative 3x equals 21. Divide by negative 3. Let me scooch this up a little bit so that I have some room, if it'll let me scooch it up. And so x equals negative 7. Okay, so this one is on here just to show you the numbers aren't always pretty. So finding negative 7/3 in Desmos might be a little tricky. Finding it on a graph might be a little tricky. So doing this by hand can be really helpful. Next example. So this one is a little bit different because now there's an x on the right-hand side. So I'm going to set up 3x minus 4 equals x and negative parenthesis 3x minus 4 equals x. And let's see how this one comes out. So for this one, the x is on the right-hand side, so I'm going to move the 3x because they're like terms. So that gives me negative 4 equals negative 2x. I'm going to divide by negative 2 and end up with 2 equals x, or x equals 2. On the other one, I'm going to distribute and do negative 3x plus 4 equals x. I'll add the 3x because the x is what's on the other side. And I'll get 4 equals 4x. Divide by 4. And get 1 equals x. Now, when you have an x on the right-hand side, not in the absolute value of some of these equations, you have to make sure that you can actually get these correct answers. Now, what I mean by that, when I take the absolute value of anything, what is it always going to be? Well, it's always going to be positive. So when I take the absolute value of 3x minus 4, I should get a positive value. Well, one of my values here, the 2 that would go right here, is positive, so that's okay. The other value is a 1, and if I put that there, up there where the x is, that's okay. So both of these answers are okay. If one of them had been negative, I would have a problem because absolute value can't equal a negative. Now, I'm not saying that you can't get negative answers because remember on the one above, we got -7 and -7/3. That was okay. But because this one has an x on the right-hand side, then you always have to check. And we're going to see that in the next example. Let's take a look. So for this one, I'm going to set up my two equations. So x plus 24 equals -7x, and negative x plus 24 equals -7x. So then I'm going to subtract my x on the left-hand side and get 24 equals -8x. Divide by -8 and get -3 equals x, or x equals -3. Now don't discount this one just yet. Let's solve the other one and then we'll talk about it. So I'm going to go ahead and distribute. I get -x minus 24 equals -7x. I'm going to add the x because there's an x on the other side, so we're going to say plus x. I'm going to do -24 equals -6x. Divide by -6 and get 4 equals x, or x equals 4. All right, let's talk about these two solutions. One positive, one negative, and we're worried about negatives. If I take -3 and I plug it back in up here, is the right side of the equation going to be positive or negative? Well, I'm going to have -7 times -3, which is positive 21. That's okay. This one's good. If I do the same thing with the 4, and I take this and I put it in up here, -7 times positive 4 is -28. That's a negative number. That's saying the absolute value equals -28. That can't happen. This is what's called an extraneous solution. Because when you plug it back in, it doesn't work. So the only answer to this is x equals -3. Okay, so when you have x outside of the absolute value, always check for those extraneous solutions. All right, next example. And last one. Looks like we're going to have to do a whole lot of work, but we're not. So this one says absolute value of 5 minus x equals -7. There's no x on the outside. But what did we just talk about? Can an absolute value equal a negative number? Can't happen. So because this is a -7, we can say absolute value cannot equal a negative. So we don't even have to bother trying to solve this. This one is not a possible problem. So we're going to say no solution. And that is solving absolute value equations, part 1.